Russian doll? What's that got to do with anything? More than you might think. So let's find out with Integrated Project Doll, delivery. In traditional and most current construction projects, tiered structures exist within project teams which nurture hierarchy and fragmentation. This is illustrated with the Russian doll paradigm. A client and contractors sit at the top, and the specialists, facilities managers and end users sit near the bottom with little input into the design process. IPD advocates an equal involvement ethos, empowering lower priority members and involving them early on in the design to facilitate collaboration. This collaborative process helps increase value for the client by addressing all requirements and involving specialists and subcontractors early on to iron out costly issues that may arise later on. The IPD process aims to create transparency between stakeholders to create an agreed set of values and a shared risk, but most importantly a shared reward which helps build relationships. Integrated projects bring the project team into a single body or doll which contains the processes of each party and stops them drifting off in different directions and working in isolation of each other. This integrated team is then maintained throughout the project, working collaboratively and with transparency to reduce wicked problems and facilitate smooth interaction between the design and construction interfaces. The IPD approach views value as an ongoing whole-life process. Post-occupancy evaluation and reflection on the project is key to successful IPD to create a closed learning loop, allowing for continuous improvement on the next project. This is a fundamental process for effective lean production. IPD, however, is not without its issues. Having such a diverse team up front so early on in the process increases initial costs and risk and can make managing design inputs very complex. So from IPD we move into target value design, or TVD. The stages of TVD begin with a demand or a requirement for a product. In this case, we're going to use a house as an example. The client or supplier initiate the process by coming up with a business case which establishes the requirements and attributes for the end product, particularly in terms of cost and function. Other considerations are how value can be maximised by involvement of the right designers and suppliers up front, and what the future market conditions for that product may be. This drives the design and target cost accordingly. To establish these points, the project team carry out a market analysis using current and historical data to find trends and predict future demands in order to set a benchmark price. This is what the consumer will be charged for the end product. Here lies an element of risk regarding the availability of reliable cost data. Often the benchmark price is based on corporate databases and past project data that can be out of date and not specific to the product. Therefore, the predicted benchmark may be inaccurate. Once the benchmark has been agreed by the contractor and his suppliers, the building contractor can work backwards on the benchmark, allowing himself a reasonable profit margin and setting a target cost for the delivery of the house. Once the market analysis has been completed, TVD stipulates the use of a cross-functional and strategic workshop involving disciplines from architects to engineers and suppliers to produce a rationalised design based on product budget and functional requirements. This is a collaborative method of producing a scheme design in which all parties involved commit to as a unit, not dissimilar to the notions of integrated project delivery. After scheme design, the house is broken down into individual components and a cost percentage allocated for each element. For example, for the roof of the house, the roof designers and specialists work in design clusters in order to select individual components such as roof tiles, membranes and drainage. Here we have the rationalisation process that the design clusters go through in order to select suitable components. Firstly, does it meet the functional requirements needed? Then, does it meet the allocated cost? If there is a cost gap, a component is rationalised by looking at different aspects such as simplification, manufacturing methods and value engineering. This is where having a cross-section of designers and suppliers is key to share knowledge and expertise. Once the component has gone through this process, it is then analysed again to see if it meets the function and cost requirements before it can be selected and passed through the project gate. Although this clustering arrangement of rationalising design is effective for selecting individual components, it can lead to fragmentation between different design clusters who are focused on their individual elements of the project rather than working collaboratively as a whole. This separation into clusters hails back to the problems encountered in traditional design processes. The components for all the building elements, e.g. roof, walls, floor, windows, doors, are all assessed as a whole as part of a permit stage, where various bodies such as building control verify the design as suitable for production. The house can then be assembled with a much higher chance of meeting the targeted cost and creating more value than traditional cost-plus approaches.
The following will attempt to elaborate on Mossman, Ballard and Pasquire's comparisons between lean project delivery and traditional approaches from their paper in 2010.
The traditional culture links directly with risk, blame, and finger pointing. They go hand in hand as they are part of the unproductive and slow nature of the construction process. Every man is aiming for the ultimate individual reward, which impacts on sharing skills and taking on less responsibility, so there's less chance of being blamed of any failures. The lean integrated project delivery culture is to continuously learn and improve. The method of Kaizen drives continuous improvement through problem solving and creative thinking. In order for the client and other stakeholders' deadlines to be met, a realistic approach must be had. True costs from past projects and reliable data must be used to give a true time frame of completion. The traditional approach uses legislative contracts as a framework to coordinate projects, although this is extremely restrictive and only promotes disputes rather than collaborative problem solving. Latham 94 suggests that there is a great concern with the lack of integration of different areas of expertise needed to specify, design and construct. Project fragmentation occurs as there is little incentive for project teams to learn together. This is mainly as it is highly unlikely they will work together again. Lean integrated project delivery has new ideas and ways of thinking. These are encouraged at all levels of management. Responsibility is shared, along with the rewards, and continual collaboration is a must in order to deliver the client's needs. Traditionally, risk is individually managed, and it is decided by individual managers what is done, and when, and by who. In doing this, the risk is transferred from person to person, job to job, and responsibility ends up getting lost in translation. Lean integrated project delivery has several ways of reducing the inherent risk. For example, iterative planning, public commitment, and the integrated form of agreement, an IFOA. The risk should be collectively managed after public discussions and responsibility has been appropriately shared. Traditionally, in complete contrast to LIPD method, drawings are completed to a 2D CAD level and then printed. This is extremely time consuming when alterations need to be made. The client's needs often get lost in translation. The traditional way is an analogue approach in a digital, continually developing age. In Lean integrated project delivery, the virtual process enables a team to collaborate and highlight any future potential issues, saving time and costs for all stakeholders. The traditional processes are very linear, and for example will go from architect to structural engineer without any input from other disciplines. This links with the traditional way of working within the siloed, over-the-wall approach, as a discipline will happily work on their own small part of a project, and once complete, metaphorically, throw it over the wall to the next discipline in line. Lean integrated project delivery doesn't allow for discrepancies in change management, as concurrent collaborative workflows allow multi-level disciplines access to live project information at all times. Weekly work plans, WWPs, is the sum of a promised task. These can be used as a guide on a daily basis. In order to publicly assign tasks, there needs to be a high level of trust and respect within the team.
Current thinking in the construction industry forces organisations to define themselves as specialist silos which function within their own comfort zones. They neither advise nor allow anyone else to actively know what they are doing for fear of losing control or accepting responsibility. This organisational system enforces fragmentation throughout the industry, as it is a fear-driven organisational design with no time for review or improvement. Collaborative IPD promotes a learning organisation. This is the creation of an organisation which delivers information at the right time dependent upon a project's needs, in order to achieve optimum efficiencies in both inputs and outputs, and to constantly improve in these efficiencies. Tools for reviewing the value and flow of their progression and work processes are implemented to streamline the organisation's efforts. Traditional construction project management is focused on a need-to-know basis, where everyone need only know what their specific role requires of them. This leads to interdisciplinary clashes at design stage and costly problems on site where no one takes responsibility. The IPD process promotes an all-for-one attitude. The system is designed so that the competent and trusted workforce know as much project information as early as possible. The messenger is rewarded rather than silenced, and honesty is key. The general rule for compensation in traditional construction projects is to attain maximum return from minimal effort. Change orders and delay costs are added up generally to the economic detriment of the client. In collaborative IPD projects, the team's economic success is dependent on the success of the project, when marked against the key performance indicators and stakeholder values set out at the offset. All team members stand to gain equal shares in compensation, having undertaken equal risk over the course of the project. Utilising tools such as BIM, creating the project in a virtual world before it is physically constructed, and reviewing informed decisions by implementing tools like the Last Planner help to ensure that the project is on track to meet all of its value criteria. In traditional construction, there is purely a contractual business agreement with the client. This leaves very little consideration for the stakeholders' needs and wants, and concern for client value is virtually non-existent. The IPD approach ensures that through constant review of progress marked against key value requirements, all stakeholders' concerns are kept at the centre of the project. Key project values are design criteria, not simply aspirations. Traditionally, interdisciplinary consultations are only sought at the moment of need as a firefighting solution. In an IPD project, all required disciplines are brought in as early as possible in an effort to find design solutions prior to known risks becoming time-consuming issues.